Hello, and welcome to Game Revolutions, the series where I write my own video game from scratch using my CoCo and assembly language. Because I really want to play Moon Patrol, and I figure writing my own Moon Patrol clone from scratch has got to be easier than figuring out how to get MAME to work.
Oh no he didn't. MAME burn, criticizing the usability of the popular arcade machine emulator.
Obviously, I'm kidding. Writing this is much harder than getting MAME to work. Today, it's time to work on crash detection. When has the car been defeated by a hole or a rock? So, 1, we will add code to determine that the car needs to crash. And 2, we're going to create an animated crash sequence showing the car to blow into smithereens and fly off into the sky, and then reset back into the game. And we're doing all of this in a very special 2-part episode of Game Revolutions because there were just so many bugs, and I mean so many bugs, they could not all fit into just one video.
Oh no he didn't. Self-burn, criticizing his own coding ability.
Our first step is to add code so that the car can detect that it did something wrong, like plowing through a rock or falling into a hole. If you look in the upper left-hand corner, you'll see this is where I had that temporary indicator to show that the joystick is up and so the car should be jumping. I added that a while back before I even had any jumping. I haven't needed it in a long time, but I still have it. So I'm going to simultaneously remove this and then add it back again, but this time to indicate that the car fell into a hole or the car hit a rock. That way I will know that the hit detection is working now for the car to determine that the car has lost a life without having to actually add all the code to deal with that. And here's the code to detect if the car got itself into trouble. I'm calling this crash detection or car hit detection. It's happening in the routine that draws the obstacles. So this draws the holes, this draws the rocks. And the very first thing it does is it asks, is the car in the middle of a jump? It doesn't matter how high off the ground it is. If it is in the air at all, I've just decided that it is quote unquote impossible for it to have crashed into an obstacle. This means that if you jump at the very last minute and you're approaching a rock, you may not have jumped high enough, fast enough to truly clear the rock, but I don't care because A, this is easy, and B, I want the game to be kind of easy. I hate those games where you have to be like just exactly at the right exact moment or else it doesn't work. I like it to give you a little leeway. So this is giving some leeway. If we're in the air, if we're airborne, crashing is impossible. The next check is we take a look at the type of the obstacle, and as you may recall, not only are holes and rocks obstacles, but explosions are as well, just because it's convenient to be able to reuse all the code between holes and rocks for explosions. So it's okay to plow through an explosion, that's not going to cause a crash, so I'm going to let that be. Next, it's time to actually do some hit detection or crash detection. So on entry to this routine, A is going to be the obstacle's current offset. This is from the left-hand side of the screen, some number from 0 to 31. And I've just loaded B with the obstacle's type. So what I'd like to do is to preserve them, and also putting them on the stack allows me to do comparisons. So on entry to the routine, we know that S is pointing to the return address. So now I'm going to push B and then A. So our stack is now pointing here. And I now overwrite the A and B registers by loading D with car LRT. This gives us the offset into the screen buffer where the lower right-hand corner of the car is. I do this little trick that I showed you last time, where by taking the remainder when dividing by 32, I end up with just the horizontal offset of the lower right-hand corner of the car. So B will now be a number from 0 to 31, which tells you where the lower right-hand corner of that car lives horizontally. And now I can do this. I can compare that car horizontal offset with wherever S is pointing. And S is right now pointing at A, which is the obstacle's horizontal offset. If the car is to the left, then negative, no crash, we're fine. Otherwise, I do a similar trick to what I showed you last time. I subtract the width of the car and the width of the obstacle from B, and then I compare B again with the obstacle. This effectively compares the left-hand side of the car with the right-hand side of the obstacle. And if it's too big, once again, the check is negative, there is no crash. Otherwise, if I made it here, we have a crash. And so this is where I added back that red line indicator on the upper left-hand side of the screen. And that's it. That's pretty much all the code that I added. All right, so keep your eye up here. Good. The indicator showed up for the whole duration where the car was in the rock. Very nice. Now what if I'm jumping? Nothing. Jumping. Nothing. Good. Now what if I mistime it and jump onto the rock? Yep, we saw a bit of that. Hole, very nice. Hole, very nice. Let's jump. Maybe I'll jump too soon. Oop, very good, very nice. Good, landed kind of in the middle there. Land in the middle there, very good. Okay, I think that's working. Time to move on to the fun part. We're back in Draw Obstacle. This was that temporary code to write the indicator that lets us know there was a crash. And now I've added this temporary jump. So regardless of the state of the stack or how many subroutines we're in or what we've saved onto the stack, for now I'm just going to temporarily go to this loop to show the explosion and I'm not coming back. This is just so I have something quick and dirty so I can see what things look like. Eventually, I would probably need to come back here and I would need to branch out of here. But that all depends on where I really want this code to live. So I might change my mind on that. But for now, we're going straight to main car explosion loop init. Think of this as a new main loop, but only for when the car is exploding because we don't want to do anything we normally do in a main loop. We're not scrolling the mountains. We're not scrolling the ground. We're not doing bullets. We're not jumping. We're not doing anything. The whole game comes to a stop so we can watch the car explode. The kind of thing I'm going for is something like this, where in the original Moon Patrol game, the car just falls apart. So I want it to fall apart, but I'm thinking maybe I could send things flying off into the air, kind of go big, trying to not be exactly the same as the game, trying to show a little personality. So now let the car just kind of just explode wildly and fly off into the air. So the main car explosion loop is going to make use of these three variables which separate the car into three pieces. We're going to have the entire upper half, and then the lower half is divided into two pieces, so 2/4 of the car, the left bottom quarter of the car and the right bottom quarter of the car. These variables tell me the lower right hand corner of each of those three pieces as they're in the process of exploding and flying through the screen. In order to initialize for the loop, for the explosion loop, we load U with the beginning of the graphics buffer that we're writing into. We load D with the current offset of the car. We adjust D to go up 6 lines. So now D is pointing to the lower right-hand corner of the upper half. And so that's what we store to initialize that first variable, the car's top lower right-hand corner. For now, I am not doing anything with the left and the right bottom of the car. I want to do things piecemeal to see how it looks before I put too much investment into the code. So eventually I'm going to initialize these two as well in that portion of the code, but for now we're sticking just with the top half. The next thing I'm going to do is fill in this buffer with the actual bytes of the top half of the car. I adjust my U to point to the very top left. I adjust my X to point to that buffer at the end, and then I have a helper routine here to blast the bytes from U into X. And finally, I'm going to fill in this buffer here. So this remembers what was on the screen behind the car. And to start off, it's just green. But as the car flies around through the screen, it's going to go up into the mountains and up into the sky. So this is not always going to be all green, but initially it will be. So I just blast that buffer with bytes of green. And finally, we're ready for the main loop. So part of this looks similar to my regular main loop. I enable the vsync interrupt. I wait until vsync. I disable vsync so I can do stack blasting. I then do the work. Move car pieces is the routine that animates each of the 3 pieces of the car moving. And then I branch back up to the top. So you'll see this is just going to keep going on and on and on. It's never going to terminate. Again, I'm just testing stuff right now, so I'm keeping it very crude. So the work happens here in move car pieces. At a high level, all this is doing is first erasing the current location of the car top, and it's going to do that again with the bottom portions as well. It advances the location of the car top up by a line. We're going to make this a bit more interesting, but for now, we're just going to have the top part of the car just zoom up the screen. And then we draw the car in its new location. Now it's important to point out I am not doing double buffering here. If we go back to the main loop, all I'm doing is synchronizing with vsync, but there's never any exchange of buffers. The other buffer has the mountains and the ground in a slightly different location. If I were to switch back and forth between the 2 buffers, everything would kind of jiggle back and forth. So I would have to initialize the other buffer with the current location of all the mountains and the ground, and really it's unnecessary. If I can get all of my work done before the scan line of the VDG reaches the top of the screen again, everything should be smooth without any tearing. And I'm doing such little work now, I don't really have to worry about not getting things drawn quickly enough. So I'm just going to continue writing into this last buffer every frame of animation and just get those frames drawn so quickly that by the time this is hit, we're well ahead of the scan line, and all we're doing is we're allowing the scan line to catch up with us. So let's dig into these 2 pieces. First, we erase the exploded car top. There's really not much to do here. All we do is we take whatever was in the background behind the car and we copy it to where the car is now. The interesting part is this copy masked piece, for which we need to set up a whole bunch of parameters. The hope is that I can reuse this for all 3 pieces of the car and just set up parameters differently for each one. Copy masked piece will copy an entire rectangle of a sprite somewhere on the screen, and it will try to bit mask things in properly. So the heart of this is right over here. A is a single byte from the screen within a nested loop that we are going to copy on top of. We AND it with the bit mask so that all of the bits that we actually want to copy are zeroed out. Then we OR that byte with the next byte from the sprite. For this to work, we want to ensure that the byte for the sprite has zeros wherever we don't want the sprite to appear. So the part that we're masking out should be 0, and the parts of the sprite we actually want to retain are non-zero. And then finally, we write that byte to the screen. So I'll come back to this routine as a whole, but I just wanted to go over how the bit masking works so we can see how the bit mask gets generated. You can see what happens if I don't do proper bit masking by looking at some of these past bugs where accidentally the car is flying through the air instead of going on the ground. When it's on the ground, I don't need to do any bit masking because everything there is all green around the car. But if the car ends up anywhere else, then all of those green pixels show up and make the car look perfectly rectangular with these extra green pixels filling everything out. I don't want this to happen when it flies through the air as part of a crash, because that would look really cheap and ugly. So I wrote yet another Java helper, bin to mask. What it does is it takes a binary of a sprite and generates a mask out of it given a particular background color. In this case, it's reading the bytes of the car from the original sprites.bin from a long time ago. And you've seen these parameters before, things like it tells it how far to read into the file before looking at the bytes, and how many bytes to look at, and how many bytes to output per line. But this plays the pivotal role. For each byte that it reads out of the file, it takes a look at 1, 2, 3, 4 pixels. Each pixel is a pair of bits. So for example here, we'll look at the upper 2 bits, which is the upper pixel, and we ask if it's different from the background color shifted to the left by 6. That way we're actually comparing the background color pixel with that upper pixel. If it's different, we zero out those bits. If it's the same, we leave those bits, which we initialize to be all 1, 1, 1, 1 in the very beginning. So what this does is it ensures that we'll have a 1, 1 wherever there was a background, and we'll have a 0, 0 wherever there was a sprite. So after this is done for all the bytes, then the result gets written out. And this is what it generates. So this would be the bit mask for the car. So back to the routine. It's basically just a nested loop. The outer loop goes over each row, row by row, and the inner loop goes within a row, each column of that row. All of these parameters you saw me set up aren't very complicated. They just help customize what's going on for the particular sprite I'm looking at. How many columns, how many rows, where do I find the area in the screen buffer that I'm writing to? Where is the buffer of the sprite start? Where does the bit mask of the sprite start? And then I ran out of registers, so I'm just using a variable here. This keeps track of the original bytes on the screen so that I can erase it for next time. All right, let's allow ourselves to crash. Oh, okay. We are definitely allowing ourselves to crash. Maybe that was a fluke. Let's try it again. Maybe we'll, jump over that first rock and then all of that code just to do nothing. All right, so quite a bit later, after a bunch of MAME debugging, I believe I understand the cause. I thought maybe this is like going off into Never Never Land, and of course eventually it does, because we do keep moving the car up and up and up and up and up and up, and eventually the car is going to go into places that it's really not supposed to go into, and terrible things will happen. I was just hoping to see it rise up before that happened. So I believe that bizarre, weird change in video mode that you saw the first time is probably just due to this causing a crash. Why didn't we see the car rise up? That's kind of a funny story. So you know how I'm doing double buffering, but I'm not doing it here? Well, as I do double buffering, I use this variable graph to tell me where to write. And I'm always writing to the off-screen buffer. So I was doing all of my work in the off-screen buffer, possibly correctly for all I know, but I never got to see it because it was off-screen. Here's the fix I'm going to try. Now at the very top of the main cart explosion loop init, I swap the buffers. This is not going to change the value of the graph variable, so I am still going to be writing to what was the off-screen buffer, only I am going to be looking at the off-screen buffer, so the off-screen buffer is now the on-screen buffer. VDG swap buffers is actually the thing that handles enabling vsync, doing async, checking to see what I'm going to swap to, either this or this, and then eventually coming back, doing yet another sync, and then returning. Is that one sync too many? You can never have too many syncs. I'll tighten this up later if I need to. Okay. Oh. Oh, yeah, and there it goes. Car went up too high. Let's watch that again. Here's our top half. I mean, that looks pretty, yeah. It's like nothing is happening with the bit masking. It looks like it actually did the ascension properly, but all that work I did for the bit masking, Okay, so you're gonna laugh. I know I laughed. When I initialized the everything before the loop, I left myself this little to-do reminder. Use Java to fill out the exploded car top mask. I never did that. I never filled out the mask. So, so we just needed to do this. Just paste in what the Java helper gave me rather than looking at it, nodding, and feeling self-satisfied. Anyway, now I am self-satisfied because it's going to work great. Let's go. Oh man, come on. I just fixed it. Come on. All seems hopeless for our intrepid adventurer. Will he ever learn how to code? Find out when the saga continues with Part 2 of Cycle 21 of Game Revolutions, coming soon.